Hello, welcome to this video. In this video I'm going to talk about how to use the golden ratio in photography. But before I do that, I'm just going to give you a little background onto how the golden ratio came about. So Leonardo Fibonacci, he was born in 1170 in Italy, and he was an Italian mathematician. He wrote Liber Abaci, which is translated to Book of the Abacus, and he worked on mathematical problems and he discovered the Fibonacci sequence. The Fibonacci sequence is a series of numbers, and what it is to find the next number in the pattern, you need to add it to the number that came before it. So it's a total, the number is a total of itself and the previous number. So the first number, number 1, that is 1 add 0 would be 1. Then 1 add 1 would be 2. 2 add 1 would be 3. 3 add 2 would be 5. 5 add 3 would be 8. 8 add 5 would be 13. 13 add 8 would be 21. 21 add 13 is 34. 34 add 21 is 55, and etc, etc. So the sequence is the number added to the previous number, like that. So phi is the number that represents the golden ratio, which is 1.618033988, and it's an irrational number. It goes on forever. The pi symbol is that circle with the line through it, or the other one that looks like a P. And the mathematical equation is phi equals 1 plus the square root of 5 divided by 2. So if you add 1 to the square root of 5 divided by 2, you'll end up with 1.618. So if I want to draw a rectangle, that's a golden rectangle, I would need to multiply the shortest side by phi, which is 1.618. So I'm going to just put in here the height of the rectangle. So if we say it's going to be 2000 pixels, and if we use a calculator, and if we times 2000 times 1.618, we get 3236. So we put in here 3236, and then if we just click in there, it's got the ratio here, and we'll just say OK, and then we've got our golden rectangle there. So using the measurements from that rectangle, the pixels were 3236. I'm going to draw a line which is 3236 pixels in length. And you can just check to make sure just by going on to that. This is Photoshop I'm using, and I can just make sure that is the right length there. So I'm drawing a second line. This time I'm drawing at the length of the shorter side of the rectangle, which was 2000 pixels, so that was easy to remember. I'll just check that's 2000. And then because I've got these together parallel, I can then draw a line on the top where that would intersect. So now I've drawn a line so it intersects at the 2000 pixel mark. So here's the finished diagram I've just made in Photoshop. So I just wanted to show you the golden ratio in relation to a straight line and where the line intersects. So I used the measurements from the golden rectangle, the 2000 pixels, the 3236 pixels, those are the measurements from the rectangle. And obviously if we minus the 2000 pixels from the 3236, we're left with 1236 pixels here. So the total length of A to B is 3236 pixels. The total length from A to C is 2000 pixels, and the length from C to B is 1236 pixels. So the golden ratio is of any kind of like straight line where it intersects is AB, so the length of AB divided by AC is equal to AC divided by BC. So we can try out that calculation. So we want AB, which is the 3236, divided by AC, which is 2000, and we get the golden ratio number 1.618. And then if we do, we'll just cancel that. AC, which is 2000 pixels, divided by BC, which is 1236, we get 1.618. But obviously the numbers go on a bit longer, but to round it off, it's 1.618, which is the golden ratio. So so anything, any kind of building or artwork or photography where you have a dividing line where it intersects at the golden ratio, it is supposed to be more aesthetically pleasing. And there are a number of buildings that are using these properties and using the properties of the golden rectangle as well. Some buildings have been shown to use the golden ratio, such as the ancient Greek temple in Athens, the Parthenon, which was constructed in 432 BC. And also, like the Great Pyramid of Giza, they've found inside the patterns of the measurements are golden ratio. And also the Taj Mahal, some of their measurements add up to the golden ratio as well. So, I mean, some people say that's not true, but other people say it is true. So it just depends on if you believe it or not. It's not a fact and it's not a fiction. It's like a theory. They also say the golden ratio is in the human body as well. What is most aesthetically pleasing in the human body, like for models, for example, like in the contests that they've had in the past, like the Miss World contests and things like that, they used to think that the perfect human, like a woman's body, used to be 90, 60, 90. So that's 90 chest, 60 waist, and 90 hips. They used to think that was the perfect shape, like in centimeters, that is. And times have changed and now they don't think that anymore. But the golden ratio, what that is saying is, if your waist is 60, which is around 23 inches, your hips should be 97 centimeters, which is around 38 inches. So that is what the golden ratio is in relation to the human body. And it also shows the golden ratio as in relation to the height and where the navel is, where it's cut off there. So the relationship between A and B and C is the same relationship there with the height and where the navel is. Now for a man, what they say for a man, what's aesthetically pleasing, if his waist, if you times that by the 1.618, you would get a shoulder length of 128 centimeters. So that's 128 centimeters around where his shoulders are. So that is what's seen as aesthetically pleasing for a man in the golden ratio, to have a waist, which is, if you times your waist by 1.618, you should get the perfect shoulder size. And for a woman, if you times your waist by 1.618, you should find out what your perfect hips size should be. So this is what they suggest is the golden ratio, but there's like other body parts as well, in the face, where they've worked out the measurements between the eyes and the nose and the lips and things like that. So they have calculations of what the golden ratio says is the most aesthetically pleasing with regards to the human body. In this diagram, you can see the golden rectangle here, and what they've done is they've made a large square using this square grid, and that's the largest square they can get in that rectangle, and then they've made another square which is the largest they can get, and then another square which is the largest they can get, and then another square. And if you have a look, if you start off with here, you've got the Fibonacci sequence. So you've got 1, 1, 2, 3, 5, 8, 13, 21. So the growth rate is the Fibonacci sequence, and this is how they've created the golden spiral, because if you draw a curve from one corner to the other with the square, and then do the same in the next square and the next square, the next square, the next square, like so forth, you get the golden spiral. And the golden spiral is also shown in nature. I'm going to show you some examples of that in a short while. So if you would design and say some sort of design, if you place the thing that you wanted people to focus on in the spiral, it would more than likely draw the human eye to it, because this golden spiral is aesthetically pleasing to humans and animals. Nature seems to follow the golden ratio, such as shells like the Nautilus shell. You can see the spiral going around, and it gets smaller as it gets towards the center, or if you start at the center, they get larger as you come out. So scientists and others would say that the Nautilus shell is using the Fibonacci sequence, so it is a golden ratio, and you can see the spiral there, which is like the golden ratio. So that is the Nautilus shell, and we do find that beautiful to look at as humans. If we look at that, we would think that is a beautiful shell. It is a shell cut in half, and that's what it looks like in the center. Hurricanes are so dangerous, they cost lives, they cause destruction. But how many of you have watched a hurricane on TV and thought to yourself, that just looks so beautiful? And it does look beautiful. And the reason why it looks beautiful is because it's a golden ratio, because you have the golden ratio spiral. So that's another golden ratio you can find in nature. Here are some other examples of the golden ratio. We've already talked about a hurricane and the Taj Mahal, but also vegetables, and like the Mona Lisa is thought to be designed on the golden ratio. And you've got things like the Milky Way, and so there's another image of a Nautilus shell there, and also if you put your hands in a fist, you've got the golden spiral there. The Romanesco cauliflower is another example of the spiral, of the golden spiral. You can see it within the actual vegetable in the florets. So I've got this Romanesco cauliflower from Tesco's in the UK. Just take it out. So this is a Romanesco, if that's how you pronounce it, cauliflower, and you can see the golden spiral here. So you can trace around. If you start at the top, you can go around and around, and you can see the spiral. And as you're going around, these little individual little cauliflower like florets get bigger and bigger. So you could start off with the small and then go around till they get bigger, or you could start with the bigger ones and go around until you get to the smaller ones and get to the center. So this was the first time I've seen one of these cauliflowers, and I went out and bought one purposefully just to have a proper look at it, because I was fascinated with what they were saying about the golden spiral. And you can see even the individual, I mean that's the top, the highest point of it, but if you look at the other ones as well, if we zoom in, so you can see even the little individual ones have their own little spirals going around and around. That's what it looks like from the side, if you've never seen one before. Not all supermarkets stock them. I had to look online for the supermarkets that did stock them. And to be honest, I've never even noticed them in the supermarket before. So I'll have to eat one and just see what it tastes like. But they are beautiful if you look closely at the spirals. So that is a Romanesco cauliflower. So I've just opened this photograph I took of my Romanesco cauliflower, and I just wanted to have a look and just to see how many spirals are actually round each like floret. So I'm just going to see if I can count. I'm going to use this particular floret here and see how many spirals are going round it. So I'm going to choose a colour. I think I'll choose red so it stands out. I've got it on paintbrush, and what I'm going to do just to count these spirals is just to put like an ink mark on the spiral, just so I don't count one twice. So we've got this spiral here, and I'm going to put an ink mark on there, and then we've got this one. So that's 1, 2, 3, 4, 5, 6, 7, 8, because that one will come to here, and then we start with this one. So there's 8 spirals around each individual floret. It'll take forever to count how many florets there are, but I think that's quite interesting that there's 8 spirals going around. What's interesting about it is the number 8 is in the Fibonacci sequence. So the rose is said to be beautiful because it is based on the golden spiral. So you can either start going around like this to the center, or start at the center and then come out like this. So it is beautiful because I do think there is some truth in it, because when you look at that spiral, you do find it attractive. and it is one of the most popular flowers there are. You know, the rose, it is used on Valentine's Day, for example, to express love. So the rose itself is one of the most beautiful flowers, and what people find really beautiful. To demonstrate how you can manipulate your images so you have the golden ratio, what I've done is I've just uploaded this photograph into Photoshop, and the first thing I'm going to do is I'm going to change the resolution. So if we go up here into the top left hand corner, we can change the resolution. If you click on the 16:9, and then where it's got the 9, if you change that to 10, and then click OK. So now we've got this image as 16:10. So to get the golden ratio in here, we need to click on the crop tool, which we've done already, and then we'll go to this grid here, golden ratio, actually golden spiral I want to look at, golden spiral, and then you click in the black space. So which part of that image do you think we should try and draw attention to? Well, I think it should be the bridge. So this is Ashness Bridge. It's one of the most photographed bridges in the Lake District in Keswick. So if you go to Keswick, that bridge, it's not very far from the town centre. Ashness Bridge, that is. So what we can do is we can actually change the size of the image, so it's goes, so that little spiral goes into the middle of the bridge like that. So if we crop it there, what we've done is we've made it a more aesthetically pleasing image, and we've used the golden spiral, which is like the golden mathematical ratio, to get that bridge to be the main point of focus on that photograph. So we have actually reduced the size of the image, but it will be more appealing because that spiral is now on the bridge itself. Right, so what I've done is I've put the cropped image that I've just done, so that the spiral is on the bridge, next to the other image. So I've put it next to the other image. You can see the composition is different. So in this image there's a lot more of the hill on this side, and there's a bit more sky. In this image the bridge looks larger, the mountains look larger. So it does look, if you compare the two images, the one with the golden spiral on it, I think, is a more appealing image. It may be something you can think about after you've done your images and you're cropping them in Photoshop. You might want to think about the golden spiral. And with the golden spiral, so if we just go back to the, we'll just turn that one off for the second. And we'll just crop this back down. Right. So with the golden spiral image here, well, let's just put the golden spiral on it again, like that. So this part of the spiral here should have the most detail in it. And it has got the most detail in it, you can see. So it starts off with the bridge, and then you've got the mountains, and you've got the rocks. So most of the detail is within the spiral, and the thing you want to focus on is in the middle of the spiral here. Now it may be that your bridge or your subject that you want to concentrate on is over here. Now with the Photoshop, If you press shift on your keyboard and press O, you can change the orientation of the golden spiral just by pressing it. So you might have something up here that you want to pay attention to. So using shift and O on your keyboard, you can just cycle through the different orientation of the golden spiral like this. So there's lots of things in the world that I've designed using the golden ratio, even things like bank cards. This is the Boots Advantage card, chemist in the UK. And if I measure this, so I get the measurement of the shortest side is 5.2 centimeters. So if we're using the Fibonacci sequence for the golden rectangle, you would need to times, so just using the calculator on my phone here. So 5.2 times 1.618 equals, so if it was the golden rectangle, it would need to be 8.4 centimeters on the longest side. So let's just measure it and see. Oh, we'll start here. So you can see it is 8.4 centimeters on the longer side. I mean, you can measure it using your own credit cards, because this is the same size as the credit cards I have in my purse. And so if you measure your credit card, if you measure the shorter side, and then if you times it by 1.618, it should measure at the longer side. So a bank card, credit card, is using the golden ratio. And there's patterns like that all over. So, you know, for anything that's pleasant to look at, people are thinking about the golden ratio as they're designing it. So that could come in useful with your photography. I just want to show you some of the other grid overlays you can get in Photoshop. So to get these grid overlays, if you go onto the crop icon there in the top left corner there, and if you click on one of these, you've got all of these overlays. You can have always show overlay, never show overlay, or you can have auto show overlay. So I've got it just on always at the moment, just to show you. So we've talked about the rule of thirds in another video, and this one is about the golden ratio. So the rule of thirds, there's nothing there that's on the lines for the rule of thirds. So we know the photographer hasn't even been using the rule of thirds in this photograph. If we go to the grid, that just shows us that it lines up. The Big Ben is vertical, which it should be. And if we go to diagonal, there might be times when you want to use that. Or you can go to this one, which is triangle. There might be times you want to use that as well. So the golden ratio, it's like the rule of thirds, but these spaces are not exactly thirds. So you have one rectangle here, then you have a square in the middle, and then a rectangle. Then you've got a thinner rectangle, a smaller rectangle, a wider rectangle. And they say this is based on the golden ratio, these dividers. And it looks like the photographer has tried to use that when he's taken this image, because the Big Ben is very close to this line, and this lamp is very close to this line. You can make it so it's perfectly on the line by cropping it like that. So we've got one on the perfect line, and then if we go the other way as well, so we can actually have it, so that one's on the line, and you can make it thin enough and you can move this so they're both on the line like that. And because it's a golden ratio grid, it should be more aesthetically pleasing to the eye. So that's one image you could crop so it's in line with the golden ratio. So this one of a mother and daughter, if we just have a look, we can crop this off as well, so we can have the mother in and we could have the daughter in as well, like that. And if you wanted to crop it even further, you could move this along so they're both, I'll move this along a little bit so they're both on the line like that. And now I've got some space here which I don't want. And I've got some space above I don't want. Let's get rid of that. So that image is likely to be more aesthetically pleasing because we've got both of these people on the golden ratio lines. The next image, we've got this street scene with these boats with a church at the bottom. So if we have a look at the rule of thirds, it doesn't look like he's used the rule of thirds. If we have a look at the golden ratio, bang, he's used the church, or she's used the church on the golden ratio line there. So they must have been thinking about that when they took the image. And then this one of Big Ben here. So if we go onto the rule of thirds, haven't really been thinking about that. If we go to the grid, we can see Big Ben's perfectly vertical. And then if we go to the golden ratio, we can see the girl is bang on the line there. So it looks like he has been using the golden ratio for this image. But this part of the image seems wasted. We could have Big Ben on the other line. So we could crop this so that we've got the girl and Big Ben on the golden ratio lines. So that image should be more aesthetically pleasing than the other image. So that's how you can crop your image using this help from Photoshop with these overlays. And the golden spiral as well is that you can manipulate the image so the golden spiral goes where you want it to go. Like on the Big Ben, for example. Like that. You could have it like that. That might be more aesthetically pleasing because we're using the golden spiral to highlight that clock there. So there's a few different ways of using the golden ratio when you're editing your images. Thank you for watching this video. I hope you've learned something about the golden ratio and how it's going to help you in your photography. Until the next video, bye for now.